This is the International A-Level October 2020 paper. I think it was also the June 2020 paper, but because of the COVID and during that year, it got moved to October. This is question 4, which deals with modulus graphs. I'm going to go through that with you now, but first, if you'd like to just look at my working, go ahead and just pause the video anytime. So here's question 4, already worked out. You can take a look at what I did before. Okay, that's number B and number C. And for some reason, I didn't do number D. Right. So we have a modulus graph. First part of the question says we have a sketch, y equals f of x. X has to be larger than 0. Find f of x. Okay. So question A. What I like to do for these sorts of questions is set it up straight away, the whole thing. So if this was our f of x, so I put in this extra bracket to teach just to that this is what this means, and it's where our x equals 6. So how do I set that up? Put 21, so the whole function. And then wherever I see an x, I'm going to exchange the x for the whole function again. So the whole function inside a function. So we have 21 minus 2, and then the whole function inside there again. I'll just leave it in a bracket. So 21 minus 2, modulus of 2 minus x. Okay. Where are we? And that modulus of 2 minus x was in a bracket. Close the bracket and then close the second modulus behind the bracket there. So there's 2 moduluses because it's a function and a function. And the second part is the x is equal to 6. So wherever we see an x, we just put 6. So just 21 minus 2, 2 minus 6, close bracket, close modulus. Okay. Now I'm going to start from the inside here and work my way out. So 2 minus 6 is negative 4. Keep it in the modulus for now. Minus 2 I can just bring down. Okay, bring down, bringing everything down. Okay. When we have a modulus, which is these signs, okay, all they mean is that this will always be positive. Okay, so why is that? Modulus has got to do with distance, and distance is always positive. So it doesn't matter whether you're going to the left or if you're going to the right, you're always going to go, for example, if you're walking 4 centimeters, gosh, walking 4 centimeters, that wouldn't work out. But if you move your ruler 4 centimeters to the left or to the right, the distance is always positive, even though on a number line, if this was 0, that would be minus 4, and that would be 4. So the distance is still the same. Okay, so the distance is always 4. So if we take this modulus thingy, we know that that's going to be 4. Now there's nothing to simplify in there. So once we've got rid of the modulus, we can just replace with a bracket. And everything else is still needing to be dealt with. So let's quickly simplify everything inside this inner bracket. 2 times 4 is 8. 21 minus 8 is, I'll give you some space. 21 minus 8, 7 is 13. So everything inside that bracket ended up being 13, just to keep it going. Okay. Then 2 minus 13 is negative 11 inside a modulus. Don't do it like this in your answers. That's just for teaching purposes. I want you to see how it's gone down. Okay, so here we have a modulus again. We know that negative 11, the modulus is going to just be 11. So now we can put in a bracket because we've solved it. And then just quickly finish it up. That's 2 times 11 is 22, and we end up with negative 1. Okay, so I have the mark scheme here for you. So if you want to check the mark scheme at any time, we can. So this is, oopsie. Why? Glitchy. Okay, so for some reason it wants to do that. But anyway, it's supposed to be -1. Okay, so that was 2A. Excuse me, 4A. Now we're going to do 4B. So 4B asked us to solve equation of f of x equal to 5x. So that's just this whole thing equal to 5x. And one way you could look at this, I suppose, is if you said, well, this is equal to 5x. And this is technically correct. I don't want to do it this way. I'm going to split this up into two options. So when I look at this part, the modulus part, I can see that because this is a modulus, it could be either negative or positive. So this inside the bracket, we don't, because it's always positive at the end, we don't know if it was negative or positive to start off with. So some sort of x value could have made this negative or positive. So therefore that part inside the bracket is either negative or positive 2 minus x. So we don't know which is which. So what I like to do is just take two functions. So let me just try and make a nice line down the middle here. Oh, okay. So 21 minus 2. And if we took the positive form of this, it's this. So that's one option. And on the other side, we take the negative form. So it'll be 21 minus 2 and then -2 plus x. So I just times both in by the negative there. And so we can simplify, do this left one first. So it's -4 plus 2x, and this one is 21 plus 4 negative 2x. Okay, so just timesing in. So we have two options. Now we want where these two options are equal to 5x. So don't forget about your 5x. So it's either going to be this one equal to 5x or this one equal to 5x. Okay, so let's take a look at our modulus graph before we go any further. Okay. So the temptation would be just to solve for this and get two answers for x and be done with the question. Okay, so that's not wrong, but I'll show you why it doesn't work. So here's our modulus graph on the right, this thing. Okay, so we're working with a modulus graph, and you can see that this one on the right here it slopes to the left, so it has a negative gradient. Okay, and then this one slopes to the right, so that has a positive gradient. So one of these has a negative gradient and one of these has a positive gradient. So let's look at our two options. These two options that we have made work for this graph. So we have this one first. This was y equals 21 minus 4 plus 2x. Okay, so obviously this is, if we rearrange it in the form y equals mx plus c, then it's 2x, 21 minus 4 is 17 plus 17. So this one has a positive gradient. So this is our gradient value. So we know that the orange one is actually on this side. And I just want to clean this up a little bit. So the other one must be on the other side. So if I write that in, this is y equals 2x plus 17, and this little piece here. And on the right-hand side, we have the other one. We're just going to make it look more pretty. So that this one here, we can do this side. It's going to hopefully end up with a negative gradient. I can see that. So it'll be y equals minus 2x. 21 plus 4 is 25. Okay. And that's on this side. So you have two lines, but as you can see, the way that this graph is written is this one has been cut off because modulus graph, it's only positive on the side. So whereas this one has continued into the negative side. So just pay attention to that sort of stuff in the exam. It affects your answers. I wonder if it affects this one. So we want to know where it's equal to 5x. And if I look at my two lines, one has a negative gradient and one has a positive gradient. Well, I can ask myself, which one is the 5x actually going to touch? Well, the line y equals 5x goes through the origin, and it has a gradient of 5. So this gradient is a little bit steeper than a gradient of 2. Okay. So it's a little bit steeper than a gradient of 2. So it'll come up like this. Oopsie. And it's most likely it's going to now, if you're looking at it this way, it's going to touch the negative line. It's not going to touch the positive line. We can make sure of that, which we can check. We could make sure of that which one it's going to touch by finding this exact x, which is the next question. So I'm not going to go into that for now. But just visually speaking, it would have to have yeah, I mean, in an exam, I would be hesitant. I would kind of check both. Oopsie. No, hang on. Major glitch day. Well, I used the opportunity of the glitch to notice that I made an error in my teaching. So the gradient of 2x, I said 5x is steeper. It's the other way around. So if you take a look at 2x is steeper. It has a steeper gradient than 5x. So this will decidedly never touch the negative line. Okay. So we have only one option, and that is if we let negative 2x plus 25 equal to 5x, that will be real. That will be real on our graph. Right, so let's quickly finish that up. Do it underneath here. So negative 2x plus 25 equals to 5x. Because I always like to bring us the positive side. So 7x equal to 25. Divide both sides by 7. And we get x is equal to 25 over 7. And we can check the mark scheme, but that should be right as your only answer, because the other one is not real for this particular function. Okay. Number C. So they give you some more information. They give that the equation of f of x is equal to k. K is some sort of constant, but it has exactly 2 roots. Okay, exactly 2 roots is important information. When it has 2 roots, a possible value of k. See, that's not a k. Okay. Let's look at our picture here. So this is the original. Where does this have exactly 2 roots? Well, it has 2 roots. So if you look at this is f of x, it will have exactly 2 roots between here and here. Now, how do I know that? If you move the whole function down to here you're going to get some sort of k value. So the question asked, okay, f of x equal to k. So we're saying some sort of k value is going to bring it up or down. Okay, some sort of k value is going to bring it up or down. Another way of looking at it is this f of x minus k, minus k equals 0. So some sort of k value is going to bring the whole graph up or down, and they're asking which one will make sure that it only cuts the axis twice. So I'll draw some options for you. If we bring it down, so a k value that brings it down, when we get to here, when this part touches, is that it's still got two. It's still got two options. However, as soon as we get to this point, which is the point of intersection between the two, it's going to only have one root. So to look at how that looks, it's just look like something like this. Okay, so as soon as we get to that point, it's only going to have one root. So from there to there. Now I'm moving it down. If we move it up, so this is what it looked like originally. If we keep moving it up, so we're saying plus some sort of k value, so plus k, then this thing is not going to have more than one root ever. So if you look at this, it's just going to get further and further away. I mean, like to draw a super long line. So it's like, okay, it's still just got one root. So the only way to get two roots is between here and here. Okay, so from this point to this point is where it has exactly two roots. So that's the math behind it. Let's look at the actual, how do we work that out? So we have our, first thing we need is, what is this y here? So this y would give us the y that we need to go from. And then the second thing is, what is our y over here? And that's the y that we're going to go to. Ha, glitchy pen. So hang on, let me sort out that glitchy pen. Sorted. All right, so we're going from the y-intercept, y, so the y part of the y-intercept, to the point of intersection between the two lines. Okay, so that's what we need. So let's look at the y-intercept first. The y-intercept is where the positive gradient graph equals to 0. Just grab that off my. So we had, here we go. So we're looking at this 2x plus 17, and we want that equal to 0. So maybe you can already see that sort of in your head, that y equals 2x plus 17. If we let x equal to 0, that's for the y-int. Then we're going to end up with 2, 0. And our y, whoopsie, equals 17. So then we get this point being 0, 17. Okay. So that's our y-intercept. And then we want the point of intersection between the two graphs. And obviously, point of intersection, you always know, is let the one equal to the other. So if we let the one equal to the other, I should grab the other one off there. So we have a 2x plus 17. Get the other one. Where was it? Minus 2x plus 25. Okay. Minus 2, where are we? Minus 2x plus 25. The point of intersection, this is going to give us the x part of the point of intersection. So bring, oh dear. No, we're good. Okay, bring the x's to the left. It's going to be 4x. 25 minus 17 is going to be, let's write it in. 25 minus 17, so we minus the 10, we get 15, and we minus the 7, we get minus 5. That's 10, and then minus another 2, that should be 8. So 4x equals to 8, and x equals to 8 divided by 4, which is 2. Okay. So we've got the x part, but we need the y part because k is a y value. So we're going to sub this in, sub x equals 2 into one of these two equations. I'm going to pick the left one. So 2 plus 17. Okay, that's 4 plus 17, and that equals to 21. So we know that our lowest k value, or the lowest k value is going to be, the lowest k is going to be the intercept. You don't have to write this in your workings, just for teaching purposes. And the highest k is 21. But how do we set this up? So this is this point of intersection. This is 221. Okay. How do we set this up? Well, we say k is between 17 and 21, but it's not including the 21 because as soon as you get to the 21, then there's a problem with the k, and the problem is, if I can just pick a different, I'm trying to pick a different color, it's not allowing me to do so. The problem with the k over here is that once it gets to this point, it's going to be only one root again. So we want the 2 root options. We don't want just one root. So it can't include the 21. Okay. And that was number C. So number 4D, it's new information is given. So we have some sort of transformation with this information. So our transformation from our original graph is y equals a f of x minus b. Okay. And our new graph has a vertex, which is what I call a turning point, is this. So the point of intersection and the turning point or vertex. Okay, it's just basically this thing. Okay, so the vertex, that's what we're looking at. It's been shifted, and it's been shifted from the original f of x by this a value and by this b value. So what we need to work out is what is a and b, and what do these shifts from our original f of x, what do they do? Well, the a value, it stretches or squishes this way. Okay, so the a value, if it stretches or squishes this way, also could be squishing, oopsie, the graph, then we have the, it can also reflect the graph over the x-axis. Okay, it can also reflect. But the main important thing is this a value affects the y's. Okay, it affects the y's. So we are looking at the y's, and if we're looking at the y's, we are looking at the original 21. So I asked myself, what happened to the 21 to make it into 3 in the new one? So what happened in between there? Well, it was divided by 7. Okay, so that means that our a value is going to divide the whole thing by 7. So it's going to be squishing. So you don't write divide by 7 over here. You write that a equals 1 over 7 because a is divided by 7. Then I look at my b value. My b value, ask myself, what happens? What does the b affect? Well, the b affects the x's, and it moves it left or right in opposite of what you think. So it's negative, it's moving it to the right. And if it's positive, it's moving it to the left. Always the opposite of what you think if it's inside these brackets. Okay, inside the brackets, opposite of what you think. So now the x's have been moved in negative which is to the right. So it's gone right. And so you got to ask yourself, how much to the right has it gone? how much to the right has it gone from 2 to 6? Well, it's gone by 4 to the right. So then our B must be equal to plus 4. Now, of course, if you write it in here, it would be minus 4, but B's actual answer is just this. So B is plus 4. I just quickly check that. So the answer mark scheme very cryptically only gives you the answers there. But that's number D. And I think we are done with question 4. Good.